Alright, so here's our 4.3, 4.5 practice, starting off with number 6 in this video. Alright, going to toggle to a new screen here. Alright, here we go. We're going to verify that x plus 1 is a factor, and then we're going to solve for all the missing roots. Alright, so this is going to be the power of 4, 3, 2, 1, and then we should have a 0 here, right? So we're missing 1 here. We're going to put a 0 for the placeholder here. And again, x plus 1 equals 0, and x equals -1. This is linear. So I'm going to use synthetic division. So I'm going -1 on the outside here, and then use my coefficients. I have 1 x to the fourth, -1 x to the third, -10 x squared, -8 x, and then 0. And starting with 1 here. So -1 times 1 is -1, and -2, -1 and -1 is -2. -1 times -2 is 2, and -10 plus 2 is -8, and -1 times 8 is 8, and -8 plus 8 is 0, and -1 times 0 is 0, and that takes care of that. So verifies that x plus 1 is in fact a factor. All right, so again, this is starting out the fourth root, right? So this is x to the fourth, and now we're here, and now this is going to be x to the third, right? So 1x to the third minus 2x squared minus 8x equals 0 to find my remaining roots here. I don't have any other roots, but I do notice that the three terms here all have an x, which is nice. So I'm going to factor out an x, and I have x squared minus 2x minus 8 equals 0. And then so that's easy enough, so I'm going to bring this up here. So x, and then I'm going to factor this. Factors of -8 that add up to -2. So x and x, 4 times 2, and -4 and positive 2. -4 times 2 is -8. -4 plus 2 is 8, so factoring that. And then just take the rest of these factors, set them all equal to 0, and solve. Alright, so x equals 0, nothing more to solve there. Here we get x equals -2, and here we get x equals 4. And don't forget my other factor here, where x is equal to -1. Alright, so there's the final factors of all this, and all the remaining roots. And then we'll come back to graphing this a little later. Alright, so here's number 7. -3 is an x-intercept, which is just another way of saying that x equals -3 is one of your roots, right? So this one of your answers here is x equals -3. And we're going to use polynomial division, factoring for all the remaining roots. So same concept here. Again, make sure that you don't have any missing pieces here, and I do, right? So this is x to the fourth plus 3x cubed. I'm missing the 0x squared, right? So just keep that in mind when you set up your synthetic division here, right? So -3 is my solution or my root, and I'm just going to fill in the gaps here. So I got 1x to the fourth, 3x cubed, 0x squared, 8x, and 24. And then start my process here and bring down that -1. Alright, so -3 times 1 is -3. 3 plus -3 is 0. -3 times 0 is 0, and that's 0. -3 times 0 is 0 again. And 8 plus 0 is 8, and then -3 times 8 is -24, and that gives me 0. Alright, so now this leaves me with, again, this is starting with the fourth root, and now we're down to the third root. So this is going to be x cubed plus 0x squared, right? So this is going to be plus 0x squared plus 0x plus 8, which ultimately just becomes x cubed plus 8 is what's left. And now I have x cubed plus 8, and now I got to set this equal to 0, right? And now I'm going to factor x cubed by 8 plus 8, and I'm going to do this with my formula for factoring cubes, right? And then recall that piece. Okay, so this is going to factor into x plus 2 times x squared minus x squared minus 2x, and then plus 4. Alright, so you can recall your formula for this. And then once we're here, x plus 2 you can set equal to 0, and x squared minus 4, x squared minus 2x plus 4 you could set equal to 0. This one's easy enough, x equals -2. So now you have two roots, x equals -3, x equals -4. You need two more roots, and if you could factor this, are there any factors of 4 to add up to -2? And the answer is no. So here we're going to have to use either difference of squares, quadratic formula, or completing a square. Doesn't matter what you use. I'm going to use completing a square here. So I'm going to bring this 4 over, so that doesn't do anything. And then I'm going to bring my middle term here, so I'm going to take -2. So I'm going to take -2, divide by 2, and square it. So that's plus 1. And then I'm going to add 1 here. And now I can do x minus 1 squared equals -3. Square root both sides. X equals, just joking, x minus 1 is equal to plus or minus I times the square root of 3. And then finally bring over that 1 here, and I got 1 plus or minus I square root of 3 as my last two factors. So I got two factors here. I'm at x minus 2, x equals -2, x equals -3, and x equals I plus radical 3, and 1 plus I radical 3, and 1 minus I radical 3. And those are the four factors that I have here. I have two real factors, and I have two imaginary factors. Alright, here's number 8. So we're going to determine the number of real and imaginary solutions of these functions. Alright, so the first one has a degree 4. So you should have 4 zeros here, or 4 solutions, right? Whether you got 4 real zeros, 4 real solutions, 4 real zeros, you got 4 imaginary, you can have a combination of both. Alright, and what I'm going to look at first is where does this cross the x-axis? So the fact that it's 4, even number, these should be going in the same direction, whether both up, both down, right? If it's even, if it's odd, like C here, then they should be going in opposite directions, all right? So I'm going to see where this crosses the x-axis. Remember, because your zeros are just where your coordinate, where your y-coordinate is 0, right? So this is the coordinate something comma 0. So here's 1. Keep going here, and here's another one. Something comma 0. There's 2. Comes back, here's 3, and here's comes back, here's 4. So this does have 4 intersections on the x-axis, which means you have 4 real zeros. All right, 1, 2, 3, 4. 4 real zeros, right? Your next one, part B, it's degree 2, so you have to have 2 zeros, and just remember, your imaginary zeros always come in pairs, right? So I'll put this here, I'm going to bring this down a little bit here. So your imaginary zeros are always in pairs. So you have 2, 4, 6, 8, right? You'll always have something in that sense here. So if you look at this, where does your graph cross the x-axis? Right, so if I'm looking at my x-axis here, and I'm seeing that there's nowhere that this graph crosses the x-axis. Yet some zeros exist. So there are going to be some zeros, and since this is of degree 2, then I can see that there's 2 imaginary zeros. Right? I don't see anything crossing the x-axis, so I can't read it as quickly as I did for for part A here. But it is degree 2, so 2 zeros exist, and since there's 2 zeros that don't cross the x-axis, then those 2 zeros must be imaginary. All right, so let's look at the next one. Right? So degree 5, so there's got to be 5 zeros here. I see 1. across the x-axis, and I see 2 across the x-axis. So I see 2 real zeros here. So if there's 2 real zeros, okay, cool, then I needed to get a total of 5. So if there's 2 real and I need a total of 5, then how many imaginary are there? Well, 2 plus 3 would be 5, but remember, imaginary numbers don't come in, multiples of 3. They only come in pairs. So I can say there's 2 imaginary numbers, but that would only give me 4. So if there's only 4 here, then one of these numbers, whether this 0 here on the left or one of these zeros on the right, one of these must have a multiplicity of 2. So really, here at this 0, there's a multiplicity of 2 here. So at 2, this could be something where it was like, when I solve this, it's going to be x minus 2 squared, right? And then I solve this for 0. So it has 2 roots or 2 zeros of 2 here. So there's going to be 3 real zeros. So this one has 2 and, right, so there's 1, 2, 3, because it has a multiplicity of 2. So there's my 3 real zeros, and then 2 imaginary zeros somewhere along the line on this graph, and a total of 5. And again, the imaginary zeros here must be in pairs. Right, so any multiple of 2, 4, 6, 8, that's fine. So you can't have 3 imaginary zeros. You need a total of 5. So if there's 2 imaginary here, 2 that you see, 2 that you see, some number of that you don't see. Well, if I did 4 imaginary, then that would give me 2 plus 4 would be 6, and that would be bigger than a degree here, which is why I can't choose 4 for my imaginary numbers here. So that means there is one of my real zeros had to be counted twice, giving me a multiplicity of 2 on this one. All right, so just be careful with that one and reading that. So make sure you have all 4 zeros, 2 zeros, or 5 zeros, depending on what your degree is. All right, let's continue with number 9 here. So what degree is the polynomial? Well, we can see it's y equals x cubed. Okay, so it's of degree 3. How many real x-intercepts do you see? And again, this is just me where it crosses the x-axis. Right, that's all I'm really looking for. And the only time I see this crossing the x-axis is right here. So there's 1 real 0. There has to be 3 real zeros because of there has to be 3 zeros because it's degree 3. And I can see it only crosses once. So the other 2 zeros must be imaginary. So there's going to be 2 imaginary. Right, and 2 is fine, right? Any increments of 2 is okay for imaginary numbers. And 2 plus 1 gives me my 3 zeros here. And then it says, what is the real x-intercept? Well, if you count this, right, this is -2, -4, -6, -8, and then -10. So my x-intercept here is x is equal to -4. And then we're going to verify with part E here. So x equals -4. And then part E here says, use your answer from part D to verify that this is a root. Okay, so I'm going to use synthetic division here. I'll plug in -4 and make sure it goes down. So I got 1x cubed, 4x squared, 5x, and then 20. And at the very end of this, I should get a 0 at the very end to verify it's a root. -4 times 1 is -4, and that gives me 0. 4 times 0 is 0. 0 plus 5 is 5, and -4 times 5 is -20. So that verifies, so seeing that 0 there verifies. So x equals -4 is a real 0, and then I'm left with x squared plus 5 equals 0. I'm going to solve this one here. I'm going to do x squared equals -5. Square root both sides, and x equals, so I'm taking the square root, so plus or minus automatically, it's a negative, so I, and I can't take the square root of 5 or simplify, so I have I radical 5. So there's my three roots. I have two imaginary here, so x plus I root 5, 1, x minus I root 5 is 2, and x equals negative 4 is my third root, which is my real one there. All right. Okay, so here's number 10. And the question saying, how many total zeros does the function yet have? Well, since this is to the fourth degree, then that implies that there's 4 zeros. How many real zeros are there? Well, anything on the x-axis that you see here is a real zero. So there's 2 real. And how many imaginary zeros are there? So from what we see here, there's 2 real zeros. Remember, imaginary zeros come in pairs, so there has to be some imaginary zeros here, right? Because I have 4 total here. And I guess you could have multiplicity of 2 on both of these, but that's not the case here, because if there was, then these would be bouncing back twice, right? So these are going through, so these are, whatever these zeros are, it's x minus 1, this is x plus 1, it's to the first degree, right? So it's odd here, because the odds go through. So there must be 2 imaginary zeros. And we'll get further into this as we start graphing a little bit more, okay? Hypothetically, and I'll show you guys another example. And then once we have these zero zeros of x equals negative 1 and x equals 2. So branch off this one. This one is x equals negative 1 and x equals 2 are the real zeros. And it says, using the real roots from the graph and syntactic division, find the remaining roots. Okay, so I could start off with negative 1 here. And I got 1 x to the fourth, negative 1 x cubed, negative 1 x squared, negative 1 x, and then negative 2. A lot of ones there, be careful. And then I'm going to multiply through on this one. So we have negative 1 times 1 is negative 1, and that gives me negative 2. Negative 1 times negative 2 gives me 2, and that gives me positive 1. Negative 1 times 1 here gives me negative 1, and then that gives me negative 2. And then negative 1 times negative 2 gives me positive 2, and that gives me 0. So check. Then I could do this again, and I'll do this with my second root here, which is 2. Alright, just bringing down that 1 here, and I'll repeat the process. So 2 times 1 is 2, and I get 0 here. 2 times 0 is 0, and I'll get positive 1 here. 2 times 1 is positive 2, and I'll get 0 here. And then that leaves me with a function of x squared plus 1 equal to 0, alright, which then ultimately turns into x squared equals negative 1. Bring this over. Square root both sides. And then I get x is equal to plus or minus I. So 2 roots here, x equals I, x equals negative I, x equals negative 1, x equals 2, and those are the remaining roots here. Alright, number 11. This is actually probably one of the easier ones you can do here. Not too bad in this one. Alright, so it says the area, use the given width of to find the missing length. So remember, your area is just length times width of a rectangle. And if you're looking for the missing length here, which is L, what you're doing is just dividing both sides by the width, and you're left with that your length is equal to your area divided by width. So in this case, your area is 2x squared plus 5x minus 3, and you're dividing this by your width here, which is x plus 3, which then just turns into quick and easy syntactic division, right? So remember, this one's going to be x. When does x plus 3 equals 0? When x equals negative 3, so I'm going to use negative 3 for my syntactic division. 2, 5, and negative 3 here. If you want to do syntactic division, you don't even have to. You could definitely factor this easier. Might be easier just to factor this, and you'll see that. But let's just go through the motions here. So you get negative 6, it's negative 1, 3, and 0, and then you're just left with 2x minus 1 equals 0, 2x equals 1, and x equals 1/2. Again, you could have just factored this. The other option was just to factor this 2x squared plus 5x minus 3, but just to show you if this was something bigger than that, then you can factor this easily into 2x and x. Here's 3 and 1, positive 6 minus 1, and here you verify that x minus 3, or x plus 3 is a factor, and then leaving you again with 2x minus 1 equals 0, and x is equal to 1/2. So same process here, but we went through the polynomial division to find this out. All right, and last but not least, number 12. Let's go to our new screen for this one and get this and see if x minus 3 is a factor. All right, so here we go. So we got x minus 3 equals 0, so x equals 3. So that's what's going in here. All right, x to the 4th. I'm missing my cubic function here. 10x squared I have, my cubic term, excuse me. I'm missing my x to the first term, and then I have my plus 9. All right, so when I go back in here, I got 1x to the 4th, 0x to the 3rd, negative 10x squared, 0x, and then 9, and here I did 0, plus minus, doesn't matter. And now I can start my synthetic division here. 3 times 1 is 3, 0 plus 3 is 3. 3 times 3 is 9, negative 9, and negative 10 and 9 is negative 1. 3 times negative 1 is negative 3, 0 plus negative 3 is negative 3, and 3 times negative 3 is negative 9, and that comes to 0, therefore this is a 0. So yes, it's a 0. Alright, and this leaves me with to the 3rd, so x cubed plus 3x squared minus 1x, or just x, and then minus 3 equals 0. So it's factor solve the remaining polynomial for completely with roots, and then so we're going to try to factor this all the way through and see what happens. Alright, so I don't have another 0 here that's given to me. I have 4 terms here, and they don't all have an x, so I'm going to try doing this by factoring by grouping. So I'm going to look at my first 2 terms, and from these 2 terms I see I can factor out an x squared. So I'm going to start with that. I'm going to factor out the x squared here, and I'm left with x plus 3, x squared plus 3. And then here, I'm going to factor out negative 1 here, and then I'm left with x plus 3 as well, which worked out nicely for me. Because now I have a common factor of x plus 3 in both these terms. I'll come in here on the side. So I factor out the x plus 3 here, and that leaves me with x squared minus 1 equals 0. So this is x plus 3. X squared minus 1 is nice. That's just x plus 1. And x minus 1 equals 0. So my 3 roots here, again, you can set these all equal to 0. But here you get x equals negative 3, x equals negative 1, x equals 1, and don't forget this root here from the beginning, x equals 3. So you have 4 real roots. This is to degree 4, and you're all done.